Yeah, no worries.
Theoretically, the stream is live.
If
Okay.
certainly looks like it.
Yeah, it looks like there's actually a video. I guess I need to message people, let them know the stream is live. Where's that? Okay. Yeah, so we'll definitely take a number of minutes, let people just waddle on in, keep it chill to begin with. See if people show up, how many we get. Um,
There's not that big a delay, to be honest.
that's pretty good. Yeah, I think it's probably around 5 seconds is the norm, something like that. Um, so,
That's about 1.5 seconds.
wow, that's extremely fast. Apparently, we're at 3 viewers so far. I don't know if it counts me though. So,
I'm a viewer.
yeah, there's at least one viewer. But I guess we can let viewers say hello in the chat, and yeah, I guess I'll probably just let it chill for 3, 4, 5 minutes, whatever it is, before we really get started here. See how many people we get strolling on in. Um, But I assume it'll be a pretty quiet, calm stream. Just a couple of people who are, vaguely interested, listening in the background and whatnot. Um, but we'll see.
No, this is cool.
Yeah, I mean, I need to do more work on the Roc Compiler. I've been pretty distracted and busy lately. And so obviously the best way to do that is to force yourself to do the work in front of tons of people, right? Or even a handful of people. Um, feels
Yeah,
like
well, I'm just interested to learn more about contributing. Like it's fun getting around the compiler and looking at it, but it's hard to know where to start. So
Yeah. And then I don't know what your volume is like on stream, but theoretically yours is louder than mine, and so hopefully it's not clipping or doing anything too crazy. Um, but if anybody's in stream, they can hopefully tell us that our sound is decent. You can also pull it up somewhere else and just hear it, make sure it sounds okay. Um,
yeah, sounds good. Yeah, no, I've quite enjoyed learning about platform development. This basic graphics platform was a bit of an experiment to see, okay, what's sort of the minimal thing that we could do.
mhm.
Uh,
Yeah, a
so
very
yeah,
basic, minimal Zig platform. Um, But yeah, we'll still give it a couple more minutes before we really get going. See if a few more people trottle on end, and then I'll start
do you
explaining
want people
everything.
to say g'day in the chat?
I mean, sure, anybody's that there can definitely say hello. I mean, say if there's anything specific they're interested in, whatever, what brought them in. Because I think we'll have two main groups of people that got brought in. People from Richard's tweet that don't really know that much about rock platform development, and then people who are actually in the Zulip rock community. And so they would have at least more of an idea of all the rock chat and whatnot. The
Yeah,
sounds good. Awesome.
Shritesh.
Yeah. The other thing that I have set up pretty terribly is every time I want to read chat, I have to look over here, and so then I never talk to the camera while uh, chatting. But it's not that
Yeah,
big of a
Richard.
deal. I'm a wee little streamer. I can have an inefficient setup. It's no big
I
deal.
reckon you just crack into it. Just make a start, and we can.
Yeah, I think at this point we're probably good to get going. Okay. Yeah. So for anybody interested, we're gonna do a little bit rock development, specifically a little bit of compiler development. This hopefully will be a very small project that will be well scoped and finished pretty quickly. But it's first we're going to give some background and context and kind of explain what's going on, what the issue is, give a little bit of rock ideas overall. And so as a basis, if you don't know about Rock, it's a pretty awesome programming language um, that I've been working on for about 2 years now, maybe a little longer, something like that. And there's a whole community of us that have been working on it for quite a while. It's now at a pretty reasonable state, though still has a long ways to go until it's just smooth and seamless to use in a lot of different contexts. Its goal is to be fast, functional, and also friendly to use. And so it's a descendant of Elm, which is a very friendly and nice to use language. One of the very interesting things about Roc that's kind of the core of what we'll be working on today is the fact it has a thing called platforms. Probably the best way to describe this, and keep it pretty simple, is that in Roc we have a runtime that can be swapped out. And so in most languages, even like C, you have a runtime. It's libc plus all of the system calls underneath it, right? That is actually how you interact with the environment in C. In Roc, we just kind of make this runtime much more explicit, and we do that in the form of a platform. A platform kind of defines everything that an application can do. And today we're looking at a platform called the Basic Graphics Platform. And we have the author of it also on, just as a floating voice, with us here. If you want to say hello, introduce yourself.
Hello everyone, Luke here, author of Basic Graphics. Yeah, the intent behind that platform was really just to learn about platform development. It's such a new concept to me, and it's really exciting. When I think about anything could be a platform, how does that actually work? So the idea was to build something really simple but still useful end to end, and in the process learn about it, and also hopefully find any issues that would help, I guess, contribute any issues back that would feed back into the Roc community, so that maybe this could be a baseline sort of platform or an example that someone else could come along and copy.
Yeah, and so overall this is a very nice, simple Zig platform. Fundamentally, just to show real quick, if we go to the example here of Roc Loves Graphics, actually let me open it here so I can at least get some color. And then just, cheat, use Elm coloring here. At least there's a little bit of color. Yeah, Roc doesn't have all of the language or coloring features that I need yet, but that's okay. So this is a basic graphics application that is using said platform, right? And so the platform, as can be seen here, is pretty basic in what you do, right? You're defining graphics objects. From those, you can color them, you can draw shapes. In this case, right, we're drawing a rectangle by just filling between these 4 points. And then we can draw more complex shapes, as you can probably guess by this one having all of these very exact decimal points here for its shape. And so the graphics library is pretty simple, right? You define how you're drawing something, you add some commands, and you return, and then you turn that to text. And the text version of the shape is what's then sent over to the platform and rendered.
Yeah, it's actually the TinyVG graphics format. So the text, they have a text format, so that's what the toText is. So it's just a Roc string, but the actual, the actual string is just the text format.
Yeah. Yeah, and so with the TinyVG format and running this, if we just, Roc run this Roc Loves Graphics platform, it'll take a little bit to compile, link, etc. And what we'll see is the output is there's this new file, this bird.png. And so if I, open that, we will see this little image here of the Roc logo, which was just generated from this platform. And so this is just a very basic, simple platform example trying to show off what can be done with a platform and the base idea. And so all this platform can do is generate images, right? And so if you have some sort of target where you want to generate an image, this would be like the basis. Of course, to make platforms more useful, they generally grow bigger and do more things. And so, for example, we have a basic CLI platform that can do just about anything you'd expect a CLI app to do. You know, it can access the file system, it can do web requests. It, of course, can do input and output and things of that nature. And so platforms kind of give you this flexible primitive to build off of. Also, yeah, I'm a big fan of array languages. That's why I have the, oh man, too many tabs to go by. That's why I have this BQN wallpaper. Overall, like array languages, like my second hobby after Roc. But yeah, so continuing on here, right? So we have this platform and it works. I can run it on Mac OS just fine. But there's a slight issue with it. And so we have this bundle file here. And so this is how you distribute Roc platforms, is you'll bundle them together. And so if we look at the bundle file for this application, we can see that it's building for macOS ARM, macOS 64-bit x86. Then you have x86 64-bit for Linux. And so it's building these three different forms of the platform, fundamentally. And so that's when you distribute and download it. Someone on Linux can just download and run it. And so if I go over to my Linux machine here and just SSH into it, I should be able to just run this platform. I'm not set up to actually download it, but I think I have it, yeah. So I can run this platform also on Linux, and if I were to go look at that file, right, Roc graphics, we'll also see the same bird.png, right? That said, you may notice there's a special little flag here that I added, which is linker equals legacy. And this is what we're trying to fix right now, is you really shouldn't need to use the legacy linker here. We want to use our fancier surgical linker. But when you do that...
I think it's behind your screen, your image.
Oh, the flag is behind the screen. Yeah, that's not the best. Long lines. But there's this flag here that I've now pasted to the bottom. Linker equals legacy, which is fundamentally a flag that we need in order to get this to work. Because Roc has two different linkers, a legacy linker and a surgical linker, at least for standard platforms. But when we made this distribution, we didn't generate everything that's needed to do to use the surgical linker. It's expecting this extra file here, this .rh file. And so that file is the preprocessed host, as we call it. And so now we're going to get into a little bit of how Roc links and just kind of explain that. So I guess I'll start with the core example of why the heck do we have two ways to link. Let me just build something real quick to show this off. So if we look at this Roc loves Zig example here, and I am going to build it, let me real quick move my video out of the way because I realize it's going to be in the way a lot. So I should be able to, that's not what I want to move. Move this up here. Okay. People hopefully can now see the line at the bottom of the screen because my video is out of the way.
Yeah, it looks good.
Okay. So if we look at linking, and we're going to start with legacy here. So if we look at the legacy linker, and we're just doing a really basic platform, this Roc loves Zig platform, which is basically complete, simple, hello world platform. And we run it with the legacy linker. It takes about 140 milliseconds most of the time. I've tested it a few times. And if instead we switch it to the surgical linker, we'll see that it takes about half that time. It only takes 70 milliseconds to link. And again, this is your most basic hello world platform, so times only can go up from here, right? This is about as fast and as small as you can go. And when we actually go and take a breakdown of what the time is spent at, with the legacy linker, unsurprisingly, there's 77 milliseconds in linking. And with the surgical linker, if we go back here and switch to surgical again, we see that it takes about 9 milliseconds for linking. So it's almost 10x faster using the surgical linker here. And if I want to go to an extreme example, we have the basic CLI platform, which is right now way bigger than it should be. But if I compare for the basic CLI platform, which I can do with this Hello World app, it uses the basic CLI platform. If I build it first with the legacy linker, we'll see that it sleeps for a while. We wait here. There you go. It takes a bit of time, a whole 3 seconds for this to run. And if instead we do it with the surgical linker, it takes about half a second. So when you get to something that's really large, this is huge how much faster we're capable of linking. Um, and so every platform that's released, we want to enable using the surgical linker. Um, I I think I'm going to skip going into too much detail of how the surgical linker actually works. I think that may be too much of a rabbit hole for now, but I'll give a base idea, right? So legacy linker is just using your standard like LD or LLD, right? You know, your Linux linker, etc. The surgical linker is basically our own custom linker that is patching the binary. And so it's doing exactly the minimal set of updates needed to link the application. And so, of course, it's way faster. It links a very limited set of possible applications, but every Roc app is guaranteed to fall in that limited set of possible applications. And so by making the linker custom to Roc, we're able to get huge speedups that make it basically link at the speed of disk. And so this is a huge win, especially as platforms get bigger.
Hey Brendan, this commands you've put here, roc build examples hello world.roc. Hello world is an application, right?
Yes. Yeah. So
where's the platform for that?
Yeah, and I'll actually show that right now. So if we real quick first go into examples hello world. So we'll see in this case, now cutting off the screen again, but you can see the start of it, this giant URL that is the platform. And so Roc will go and download that, and we'll actually go and look at the cache of that real quick. So if I recall exactly, what is this? So cache, oh, okay, cool. I have the thing in my path, remembered commands. So if we look here, Roc ends up caching. It downloads it into, it basically just downloads and extracts the files. And so these are the files that we're looking at when we talk about a Roc platform. And so this is the platform side of it, which the Hello World app depends on. And I guess I can highlight the key pieces here. First off, there's a ton of .roc files. This is the actual API of the platform. It's all of the things it exposes, right? You know, it exposes a file library that we can use to interact with the file system. Will the surgical linker eventually work for all use cases, or will there still be places where the legacy linker would be required? So currently, the surgical linker has one bug on Linux that I'm aware of that stops it from working for everything period on Linux. Once that's fixed, it should work all the time on Linux. We have a Windows surgical linker that I didn't personally write, so I'm not sure the state of it. But to my understanding, it works overall. I don't know if it has any major outstanding issues. And then macOS is just a work in progress, and we haven't really got there. But once the surgical linker is fully fleshed out on all these platforms, it should work on all of them. The Windows one doesn't handle DLLs. Okay. So yeah, there's still limitations. But long term, the surgical linker should be the thing used always, period, for Roc. There should never be a case that some other linker is needed. And the key magic behind this is that platforms deal with all of the I/O. So they do all input and output for the entire application. And so because of that, the Roc app never links to any I/O. It never links to any external libraries. It always is just within its own bubble. And that's what enables us to do a much more limited sense of linking. And so that should work all the time. And then continuing back here, so if we look back over here, we can see a couple of .o files. So these are all used for legacy linking, anything that ends in a .o here. So all of these
They're like the ones we built before, right?
Yep.
Using that build bundle thing.
Exactly the same thing, right? And so what you generated with the build bundle, which is just telling Zig to generate an object file, is the exact same thing as we get here. This one generated by Rust, but same thing. And then there's two special files, this .rh file and this .rm file. And these two files are what are used by the surgical linker. So this is a Roc host, and this is Roc metadata. Essentially, the Roc host is a full binary that's ready to run, minus the Roc code. And the metadata is any information we need to patch up the binary to add in the Roc code. And so the surgical linker would take those two files, add in the Roc code, and there you go. You have a complete application ready to be used. And so the fundamental goal...
If there was a surgical linker for Windows, would that also need a windows.x64.rh file?
Yes, if this platform supported Windows, it would do the exact same thing for Windows, and it would have a host and a metadata file for Windows as
Right.
well. All of the surgical linkers are based in similar code, and they do things pretty similarly, and so I'd expect it to
Mm.
look essentially the same. Yeah. Um, so yeah, when it comes to what we're trying to do today is simply trying to enable building these two files, generating these two files from any platform. And so hopefully this is a pretty small, well-scoped exercise where we can enable this generation, pipeline some commands through, because we already have all the code to do this. It's just not accessible on other platforms. And so it's pipeline it through to enable generating those. So then when we go back to that basic graphics platform, it can generate the correct files for the surgical linker. And so with that, we'll now have a bundled, distributable executable. That is, it has Mac, it has Linux, it has the surgical linker on Linux, which means it has fast linking on Linux. The other really cool thing about this, and if I go back over here, when we look at this bundle script, it's generating the Linux object file, the Mac object file, the ARM object file. All of these are generated on any platform, right? I am on Mac OS right now. It generated all those files just fine. If I was on Linux, I guess, which is what my SSH session is, it also generates those files just fine. And so if we expose a new command to do this pre-processing and generate the .rh and .rm file, suddenly you can completely bundle a Zig-based platform, or theoretically any platform, on one system using cross-compilation, as opposed to needing to deal with all of the intricacies of like, oh, I need to build on Linux and then build on Windows and then build on Mac and deal with that pain. Which, to clarify, what basic CLI does right now is that it builds on all of the different platforms to generate the different binaries. But long term, we'd like to not require that, right?
Yeah, that'd be awesome.
And so I guess now we can jump into Roc itself.
Yeah, I'm keen to know where those pre-processed things come from.
Yeah, so we will jump into that right now.
Is it the Roc CLI that does that, presumably?
Yeah, so currently, I guess I can show one more thing. So if I go back to this Linux machine, and I just print out this, oh, where would I have to go? So if I go platform switching Zig, yeah, this will work for me. So if I go here, right, it generated, when I ran the Zig platform, it will actually just generate these files directly, this .rh file and .rm file. And actually, what it generates that from is a dynamically linked version of the executable. But we won't dig too much into that here. But where it's actually generated in code is in the surgical linker. Give me 1 second. Okay. So if we go into linker, so we have the surgical linker. It supports P to some extent, ELF the best, and Mac O is work in progress. Needs to be picked back up at some point. But if we go into this ELF surgical linker, we search for pre-process, if I can type, we find this simple pre-process ELF function. And this is what actually generates those two files. It will take in a host executable, and then it will dump out a metadata and a preprocessed executable. How do I like Helix? I find Helix awesome. I am now using it all the time, even at work. At my previous job, I still used Vim or VS Code with Vim bindings, but now I've committed 100% to Helix. I guess my only minor nitpick is it has a few performance issues compared to Vim when opening stupidly large files or stupidly large repos. And so those are a little problematic. And then also it requires treesitter to do syntax highlighting, which Vim does not. Vim, you can use the language server. But overall, I find Helix really awesome.
And Roc doesn't have a tree sitter yet.
Yeah, Roc doesn't have a treesitter, though you can use the ELF treesitter and it at least looks okay.
It's not too bad, yeah.
So that's at least something. But yeah, so this pre-process function already exists. It already works. And it should work on any platform. If I call preprocess elf, it's not complaining and saying, oh, you're trying to preprocess an elf from Mac OS. At least I hope it won't. We'll see. There may be some pieces here that need more pipelining related to targets and maybe separating the target from the actual platform it's running on, but I don't think that will be an issue. And so with that in mind, if we go to, I think, if we go back into linker and we go to the lib, I think this is where we have the main dispatch function. Oh, why is that scrolling so weird? That's a little bit jerky. Okay. Yeah, we have this function. It already exists. Linked preprocessed host. And this will dispatch... oh, no, not linked preprocessed host. That's after. Let's see. There should be something else here with just preprocess in general. Let's see. Link preprocess host. Preprocess host. There we go. Slightly different name. We already have this function preprocessed host. And so hopefully all that we need to do is wire this into the CLI. So a pretty small and direct upgrade, essentially. And so let's see if I remember where all of the CLI stuff is. That's a different question. What, it's going to be in compiler, maybe in CLI? Do we have compiler / CLI? No, it's not compiler / CLI. Okay.
What are you looking for?
We have load, where the actual main CLI is. Oh, you know what I can just do? I know what it is. Program. It's not in compiler. It's in CLI / yeah, it's not in the compiler at all. It's just CLI / lib right there. So this is our main CLI, where you can see we have a lot of commands: build, run, dev, REPL, etc. Gen stub library, which will become important later. And we're just trying to add a new command. So hopefully that's not too hard to do. I don't have a good name for this yet, but I guess I'm just going to call it what it is. Preprocess host. You know, just keep it simple.
So we're exposing that internal thing
Yes. Yeah.
to the CLI, so we can pre-process things using Roc CLI. Yep.
Exactly. So if we expose this, we will hopefully be good and be able to use it elsewhere. And I'm going to actually just go to the uses of this, because I'm assuming, apparently my language server is not happy. I wonder if that's because streaming or something else. I don't know. That's fine. We'll do this the manual way. And we'll just jump down here. So if we go to gen stublib, I think we're basically going to make something that looks just like this function here. So we're going to be making a new subcommand. Just take all of these. And this will be preprocess host. I can spell. So we'll just say runs the surgical linker preprocessor. Generate .rh and .rm files. Not the best description, but it should do fine for what we're doing. In this case, I have to remember what specifically this will take as input. I guess it should...
Dyn host, maybe?
It probably will take... So it may take the Dyn host directly. Let me look back at what the API was. So if we come back over here, we need the platform main. We need the... I think that's just the output path, if I understand correctly. And then we need the path to the shared library, which is the Dyn host file. Exactly. Or it should be. Let's see. What did we do with the shared lib file? Shared lib. Oh, we just passed that in. Interesting. Let me actually follow that. Shared lib. Next one here. What do we actually do with the shared lib? We keep passing it down. Okay. What does this end up being used for? Do we use it? Oh, yeah, okay, we scan the dynamic dependencies. Okay, so yeah, we do just pass that in directly. So I'm pretty sure we can generate that, so I don't think there's a need to pass it in, actually. Never mind, I'm mixed up. I know what's happening. The shared lib here is the dummy rock shared library that we need. Okay, so I know what all of these is. So we should be able to generate this shared library. That's something Roc can generate, and that's actually what this command above us does. This command gen stublib
Stublib or something. Yep.
generates that. But we don't need someone to call that. They should just be able to call this, and we can generate the stublib for them. So that shouldn't be needed. We will need the platform main path,
So
and we will
what's
have
the
to
stub?
decide what our output path is.
Is the stublib stubbing out all the things that aren't there in the dynamic? What are they stubbing out?
Yeah, so in this case for the stublib, what we do is we generate a dynamic library for the platform to link against. And this dynamic library basically has everything the platform expects, but they're not defined. They're just empty functions.
So the platform is being built as a executable expecting a dynamic library to load a dynamic library.
Yes,
So
exactly.
Roc will generate a stub one so we can. Yep.
Yes, that's exactly what happens. And so that's what we'll have to do here. And I guess what would be useful, my language server's working, that's nice, is we can look at where this is called and actually kind of follow along with what it is doing. Because like fundamentally, somewhere where this is called, I think actually, oh, that's just the definition, yeah. Where this is called is kind of the full chain, right? They rebuild the host and then they pre-process it, right? And so we'll have to double check some things and try to make sure that we're passing everything in because we're fundamentally doing the same thing. We just aren't, like we want to do this without rebuilding the host. And so exactly what's passed in here is kind of what we want to do. But anyways, let's just start pipelining through. I guess the main things that we need are the host that is the non-preprocessed host. We can generate the preprocessed host path just based on that. So for now, we can leave that out, and we need the target triple.
So the non-preprocessed host is at the main.roc file.
So before it's preprocessed is the dynamic host. So it's an executable that dynamically links to the Roc, right?
Right. Yep.
Yeah. So let's just go
So
here.
in our sort of Zig platform example, we would stub out the external functions and build a dynamic or build an application.
Yes, exactly. You build an application and you say it's dynamically linking against the stublib.
Right.
Yeah. And so in this case, we're not going to have a flag for this yet, so we have to go back up to the top and add a new flag instead of roc file. We will just call this, what's the name we used here? Well, I guess the platform main will be the roc file, but we also need something else, or do we not? Yeah, we will need one other thing. We will need the pre-processed host. Or not, gosh darn it, wrong thing. Wait, the...
Dyn host?
Yeah, we need the Dyn host, which I'm forgetting what the correct name for that is. Like what we should call it here. But anyways, so for now, we'll just call it the Dyn host. We will get a better name for this later, but for now, that's at least something to stub to. Well, like,
Surgical host.
I mean, it probably should just be called like platform executable. Probably just something like that. Just why not? Because that's what it is, right? It is the platform executable in this case. Okay.
Yep. Makes sense.
So we jump back over here, and so we're going to need a roc file, but instead of this being the app, it will be the main.roc file for a platform. And that's absolutely required. We have a target if you want to choose a different target. I don't know why this is complaining. Oh, because we have to reference it here, maybe? That's not what I want to type. There we go. Okay. Nope, not right. Okay, let's see. What do we need here? Maybe we just need to clone it. I don't know what type of value this is. I can just look at what we did before. Because target's obviously used many times. We just scroll up to see what they do normally. See, and this is the important part with Roc development. You know, a lot of times something already exists, and you just need to find what people do with it, you know, and just copy it. There should be target somewhere, man. Ah, there we go. Target. Oh yeah, it's literally just a clone. Cool, that's not too bad. Okay, so go back to here, and we clone this function. There you go. Rust is happy. Okay, and we need one more argument, which will be the platform executable.
Is it better to phrase it the other way around? A platform.
A platform dynamically. A platform.
The platform
executable dynamically.
Which is expecting, yeah.
Linked to libapp.so. Well, I mean that's Linux specific, so we'll just say libapp. Or to a Roc app. Yeah, we'll go with that. That sounds fine. And you absolutely need to specify the platform executable, and then the target is optional. So that defines this. And now, if I just real quick go back over here to where this is used, I think that's in main. Yeah, here's where we're doing all of the matching and dispatching of functions. And so we're just adding another one in here. So this will be preprocess host, nice and simple. We can actually just copy that because that's all going to be the same. But now we also have, so this is, let's call this, what do we say, platform main path, and then platform exec path. Okay. So those are the two main pieces. What else do we need here? Yes, I know I'm not returning anything and it's angry. We have to return a result. I mean, I guess just for now to make it happy.
Let's go Roc Compiler preprocess host.
Look at that. That should be happy, right? There you go. Okay. But what we actually want to do is call this preprocess host function. And most of this should be fine. The one thing I'm missing is these stub DLL symbols. I don't know where that comes from. That's a Windows thing. I'm not used to Windows. I didn't work on that part. So it is new to me. I'll have to look into that more. But so if we just do this, let's see. Thanks for auto-tabbing. Oh, it's because I don't have a semicolon there.
How does Rust handle the target?
What do you mean?
The target there, where are we getting that from?
Oh, that was passed in via the CLI as well, right? So we had this flag target. So this is just our regular target parsing, and then we just do a from string, and so we have this basic, tokenizer with all these different serialized names. So that's just where the target comes from.
Ah, okay. Yep.
Yeah.
It's our own enum.
Okay. Arguments to this function are incorrect. Who would have guessed? When you don't put the right function names, they're incorrect. Platform main. I'll just switch that to that.
As an aside, I'm very impressed with this bot, Fossil bot.
Oh yeah, I like it. I think it's a pretty cool little bot. I've watched a tutorial on how to set up Twitch stuff, and so far it's actually been pretty useful. Do we actually have to pass in? Oh, we need to generate the stub library. Or, I don't know why this even needs the stub library, but we'll generate a stub library real quick. That's totally fine. Do we have everything to do that? We're still missing those DLL things. I don't know what the stub DLLs are. Let's just ignore that for now.
Just pass an empty,
Yeah, exactly.
empty array in. Yeah. You just need the stub lib path, I think.
Okay. See, and also the other thing I'm not sure about, I definitely didn't get types right. Okay, first off, let me just correct this. Okay, so that's correct. Why is this complaining about target? Target should be of the right type, I think. Oh, it expects a target triple. So this is the Roc version of the target. Do we have just a 2 triple? Perfect. Gotta love when things are simple, and we have to do that over here too. Does that?
Yep, we go into or something.
Oh, and it wants a reference. Sure. I type a lot worse when I'm on Twitch. Who would have guessed? Okay, so that should at least be good. Yeah, and then it's complaining about this, probably because I didn't even, define this as a variable. That may be important. That said, it might be a vector. Let's see, what is this supposed to be? It's reference.
Pointed to a string.
Oh, let me make this a slice. Okay. So that theoretically is actually most of this feature, besides the fact that I think this returns an error of some sort. Does it not? Oh, no, it returns nothing. Okay. So this can't fail, theoretically. That works with me. Okay. Oh, wrong button. Okay. The other thing that we're currently missing is, as I said, these DLL symbols. So let's try and follow that. Where do these come from? Where is this called, and how does it get those symbols? So it's called over here, in the surgical linker side, of course. Let's go to the definition. What do we get? Oh, it's passed in. Gotta follow the chain more. Spawn thread. So we're spawning the thread. Ah! Symbols from exposed to host. Oh! Will that be problematic? I think that may be problematic. We might have to think of a smarter way to do this. So essentially what's happening here is this isn't our regular compilation path. We have a host that has been built, and we have a Roc application that's been loaded. And when we load the application, we look for what it expects from the host and what it exposes to the host. And so we're using the loaded Roc application to build this. But in our case over here, I was kind of hoping to avoid depending on a Roc application at all. I was hoping just to use a platform instead of an application. But it sounds like that's not the right way to do this, and we actually still do want an example application so that we can load it and use things correctly, which now makes a lot of sense to me given this gen stublib command also takes an example application. So we will follow in the footsteps of past me who wrote that and use an example application. Past me is often smarter than current me when it comes to figuring things out. Okay.
So can you say that again? So the from exposed to host, it's wanting to look at a Roc application to see what it's exposing
to the platform
that the host would be dynamically linking in.
Exactly. So the application specifies, hey, the platform, I'm giving the platform this main function, right? It specifies that. And then on the other side, there's also all of the functions that the platform shows to the application. And there's totally a different way we could load this, but currently with our current pipeline, it's easiest to get this from an application. We have all of the pieces set up.
But long term, wouldn't we want to go the way we've been trying to go and have the platform look at what the platform's expecting to link in?
Yes, that would be better, is we take the platform main and we would use that and pull out this information. Because the information also exists there. In fact, that's almost certainly what this is doing, is this loaded file came from loading the application, right? Oh, that didn't actually go for where I thought it would go. But anyway, this loaded file came from loading the application. And when it loaded the application, it also had to load all of the Roc for the platform. And that's why the application has all the information of what's exposed to the platform, right? But in reality, it would be a lot nicer if instead of that, we just kind of loaded that information from the platform. Now, in this case, it's not too big of a deal, in my opinion, because fundamentally what you can do is just have it such that your platform always requires one sample application, right? And as long as you have one sample application, there's no problem here. Just point to that, you know, no big deal. But without that, it causes a few issues.
Yeah.
And so let me follow this and see, or follow
Is
this
it
and see
worth
what's
spending some time looking at how hard it would be to go the other way from the platform? Like, do you need to load the symbols from the dynamic host, or sorry, from the executable, or
So my big concern with doing something like that is that like loading is actually a pretty complicated process that I'm not very familiar with. Right? We have this whole monomorphized
right?
module with a lot of
So it's
information,
the
to say the
Windows
least.
part.
Yeah.
Yeah.
And so all of this information is stuff that I don't want to mess with right now. I do think that's what we should do
Yeah.
long term because I don't see a reason not to. It seems kind of silly to require an application to pre-process a platform. You know, that's just unnecessary, right? Um, but as of now, that's I guess what we're kind of stuck with.
Yeah, yeah. So good.
So
It helps me to understand what it's doing, I guess. Just sort
let
of
me jump
talking
through
that
this real
through.
quick. So if we go back, not here, I want this one. If we go back through this, where it's getting used over here, when does it get that information? It calls our generated stublib function. It then, so we have a input path, which that's where the application is. So, yeah, so it just loads the entire input in this giant monstrosity here. It's not a monstrosity, it just has a lot of config. So we should do the same thing. That is probably the better way for us to do this.
Hmm.
And if I go back to our code here, what that means is before we do, oh, not here, sorry, wrong spot. Go back to our code in main, where they just call this generate stublib here. We actually essentially want to call the same thing, but with a little bit of a caveat. Actually, can we just call the exact same thing? So if we call generate stublib here, it won't re-export these DLL symbols. Okay, that's I think what I want to do. So if we go, is this only used here? It is, cool. So we're going to hijack this and make it more useful to us because it is going to generate those DLL symbols somewhere in this function, right? Yeah, exactly. It generates these stub DLL symbols right here. And we want those, plus we want the stublib. So what I'm going to change this, instead of just returning OK0 or whatever else of that sort, right here, we're going to return both of those things. So we are going to take out the stublib itself and the actually, can I just do, let me just, do I need to have this within here? I think all of this can just move out of here. All of that's going to be the same no matter what. So we bring this up. I think that's all correct. Oh, no, it needs the platform path. Okay, so we can't do that. Okay. So we'll just make this return both of these. So it will return the stub lib and the stub DLL symbols. So that should be good. Let me just put a let. So we just do that. Let it reformat. That is such beautiful formatting, Rust. I'm so glad we have this beautiful formatting. And then we just come over here, and instead of returning 0, like we were doing before, we will return those symbols. And of course, we have to wrap them in percent. There you go. And so we'll return those symbols and those paths, because it's just going to be useful in general. And so now we come over here. We're going to have make this type correct. So this should be a tuple of a path and I don't know what the stublib symbols are. Some sort of slice is all I remember. Slice of string maybe. Is that correct?
Think exposed symbols. Of X string.
That error does not seem like what I want it to be.
Exposed stub DLL symbols is a vec of string.
Oh, it's a vector string? Okay.
Yeah.
Thank you. And I might have to change that to a path buff because of allocations. I think I need to do path buff for that. And
Stublib is the path buff. Yep.
oh, there is no error. Okay, cool. So yeah, so we change that to a path buff, and now we're over here, and of course this has an error because, well, we are returning data that we actually don't care about. So we can just do a, how do I want to do this? If let okay, so if this is okay, well, no, we'll just do it like this. So if this passes at all, I don't really care what data it has. We will just then go and return an OK 0. Okay, so now this function is more useful to us. So now we can steal it. Oh, it's going to say unused result. Yeah, that makes sense. Does this need to return a result at all? I mean, it was only returning OK before, so let's just not make it return a result. It doesn't need a result anymore. Yeah. A little bit of hijacking of this function, but it's overall worthwhile because these things will be needed in multiple places in the future. Yeah, so we'll just do that. And then actually, I can make this prettier again. Delete all of this. And just delete the semicolon off the end. Beautiful. Mind sharing my system specs. So this is an M1 Mac. So the big issue that you're seeing, if you're seeing the LSP choke on an M1 Mac or on any system really, the big issue that you're seeing is that the LSP and any other commands you run are probably fighting with each other. That at least is what I end up hitting a lot. And so for me, like, I'll often do something like this, Control Z, and then I'll do cargo, do something like that. You'll have LSP and other stuff fighting each other. And that leads to things being really slow. Or if you have in another tab, you have tests running. Every time the tests run, the LSP is not running. I know someone I work with literally has 2 different cargo target directories, one for the LSP and one for everything else. And so even though they're building everything twice, it's a lot smoother of an experience. But I don't know what you've developed in Rust before. Maybe you're just dealing with a lot slower to compile or big projects, though probably not. This is a 250,000 line project now, and it's not fast to compile. But yeah, on an M1 Mac, it works just fine for me. What does that say? To linit 0. Oh wait, you see double 3 seconds on an... Oh, no, the legacy linker 3-second thing was on my x86 machine. Though, yeah, what does it take on my own Mac? I can run that real quick. Roc build. Yeah, this is still in my... Wait, let me exit. Okay, now we're back on my main machine. Project Roc. We can real quick just sidetrack into this. Roc build. Example / hello world .roc. Oh boy, no, it's slow. It's slow for me, though. I don't know if it's using LLD. Okay, this is exceptionally slow for me, so I'm going to definitely blame the fact I'm streaming right now. Mine has never taken 6.5 seconds to link this. That's the next level of slow. We'll even run it a second time just to see. And so I'm definitely blaming streaming on the fact that this is so horribly slow. But normally I think this does take about 3 seconds for me on my M1 Mac to link this hello world. No, this actually gets way better the next time we release our basic CLI, because right now it's about, I think, 60
Just,
megabytes, and it's about to be 6.
it
And it
just
was
took
just
me 386 milliseconds on my M2 Mac.
386. Okay. Richard apparently has the best M1 Mac. 1.6 seconds. Okay. He has favoritism from Apple Silicon, is what I'm learning here. But yeah. Anyway, so
276 milliseconds on my M2 Mac.
how long did you say? Say that one more time.
276 milliseconds.
Oh, 276. Okay, never mind. That is blazingly faster than anything we're doing here. Okay, got it. I think I only have the basic M1 Mac as well. It is just a MacBook Air, and I don't think it's fancy. I don't think I got anything fancy. I don't know a command to run to check that. There's probably some command I can run. I mean, I probably can just do what? The most useful side tangents. General. It's probably about. Where's the about or something? Oh no, it's this. There we go. That is so readable. Yeah, I have a Apple M1. Doesn't say Pro or anything else like that. 8 gig. Sonoma 14.1. I've recently updated it, finally. But yeah, so the Rust stuff, though, works just fine in this code base. Till init 0. It's a little bit slow, but not bad by any means. Especially if you're talking. My talking takes up more time than the compilation. As long as I'm... now, you have to be careful, right? If I go change something that's deeper in the Rust compilation, it's slow. This stuff is all pretty surface level. It's like the last stuff that compiles. And so that makes it a lot slower. Anyways, let's go ahead and take this generate stublib and steal it, because that's what we need here, and it will give us both of the pieces we need. So, gotta love when you can just steal a feature to let it do all your dirty work, you know. And then we just need to reference this because we have a other, what's it called? My brain's not functioning right now. Those aren't named right. So input path is actually, I think, platform main path. What the heck is function kind? I guess I need to go look at where the heck. Oh, sure. I'll just follow along. Function kind has no meaning to me, and so this is an important note, I guess, on platform development and whatnot. Sometimes you don't know all of the pieces. I know lambda sets are an important part of the type system, but I really don't know how a lot of it works under the hood. But for my purposes, not a big deal. I will just follow along and pass in the lambda set because that works for generating the stublib, and that's what we're doing. So
function values are solved to lambda sets. Lambda sets are the kind. Whereas erased is function values are erased. No kind is introduced.
This is for some fancy compiler stuff that I have some vague ideas about, but it's beyond me to go into. This is one of the things eventually I should get into, is more of the type system work that people have done, but I haven't touched that for the most part. Anyways, theoretically, this is it. This should be working, having this piped through. I guess I will do one other thing here. Oh, that's not what I wanted to do. Instead of calling this twice, we'll just,
Erased is one of the things we need for task map 2.
Yes, it's needed for a lot of the fancier task stuff, because there are certain types that technically don't work, but we want them to work, and so we have erased to make that work, to my understanding. I don't fully understand the details, but that's my rough understanding. I guess Richard could pitch in if he has a deeper comment on that. Actually, let's do that. No. Okay. So now that we have this, let's go ahead and try and run it. And I guess just, to begin with, what do I call it? Preprocess host? on. See, we should get something going. Yeah, it's actually kind of impressive the language server runs so fast when like all of this is theoretically what it would have to compile, which is not that fast. Though also linking the final binary is very slow, which the language server should never have to do. Erased would be a very large tangent. I believe that. I definitely believe that. Yeah, the type system's really cool in Roc, and I definitely admire it, but I will not claim to understand a lot of it. Lambda sets are beyond me to some extent. Okay. You'd think it would give us some sort of like help description instead of just saying those aren't passed in. I guess you have to specifically say help to get the full help description. I don't like that. It should print this when you don't pass anything in. That'd be nicer. But anyways, we have all of this, but what we don't have yet is a dynamically linked version of the Roc application. So I guess we can switch gears and why not generate that real quick? It shouldn't be too hard. It should just require a little bit of extra sig fiddling on the Roc graphics side. And once we have that, we should be able to generate these pieces fully from the Roc graphics side. So if we go into Roc graphics here, I think the big thing is that we are going to, I guess I'm going to try to just do part of it manually right now. I know I won't. Okay, no, because I just realized that'll be too painful. Okay, so we go into this. There's this bundle file, which is the first part. It is going to first need to generate, oh no, it doesn't need to generate a stublib yet. Oh no, it will. It will need to generate a stublib right at the beginning. So if we go up here and we go Roc, gen stub lib, this is where I don't know the command, so I should run it manually first. Okay, Roc, Roc gen stub lib. So we want a stublib for Linux, x64. Then the Roc file is just an example application, I think. So if I do this, does that work? Okay, it didn't crash. That's good. And if we look at in the platform directory, I think, yes, libapp.so. So this is the stublib we were talking about before, and actually I can just do a quick, oh no, I'm not on Linux. I can't obj dump it. I don't have a working, do I have a working obj dump that'll work with Linux? I don't think this is going to work. We'll try it, whatever, that's fine. But I'm pretty sure it's going to complain at me. Oh, my terminal locked up. What's going on here? Well, that's quality.
Doesn't like the Linux binary.
Apparently. Okay, let's try this a second time. Let's not press tab, apparently, for some reason. It's just what? platform/libapp.so. Type that into less. We'll see. Do we get something? No. Okay. I'm assuming that means it's just printing an error. Oh, no, okay, it works. It just doesn't want to work in that way. But it's not printing anything useful. The symbol table's gone. Okay, it's just crashing when it gets to the symbol table. Cool. Yep, sorry, I can't show that off to show what's actually in the stublib. It doesn't know. Okay, whatever, that's fine. We've generated the stublib, though, and that's the important part here. So we have the platform/libapp.so. And so we need to tell Zig to link this host.zig with libapp.so.
Slow down for a second. So Cargo was cross-compiling there?
Roc generated the stublib for Linux.
So how did Roc do that? So Roc, was that using like a dev backend or something?
Ah, yeah, I can show that off real quick. So we go back into the Roc code, and we go back into the linker, and we go back into the elf linker. No, that's not where it is. Let's see if I can remember where this is. It might just be directly in. Oh, generate dilib. Yeah, there we go. So we have custom code here, create dilib.elf, that is platform agnostic, technically speaking, that will generate this shared library.
Right.
And so we are just generating it ourselves. We get to play with all of the fun assembly bits to make it work. And then you can see all of the placeholder things. But yeah, so we manually generate this ELF executable, or ELF shared library.
Based on the Roc application.
Yes.
So we look at the Roc application, look at what things it's going to expose to the host, and then generate a dynamic library, which is just stubbed implementations of those symbols.
Yes, exactly. And so now that we have the stub library, we can tell Zig to link against it. Do I still have this open? I do. So let me actually add this full command real quick to the Zig implementation, or to the bundling command. Let's actually move this elsewhere. We'll do this at the end after all of the non-surgical linked versions. Yeah, we'll put it here. And the other thing that we need to do is hope that my build.zig skills are good. This is the hard part. How do I tell Zig to link against a shared library in build.zig? Do I know how to do this? Okay, let's just go straight to the docs here.
Would it be easier just to use zig build exe against one of the against the thing we'd just built? So we've built the static library or the object file. Can't we just link that with the stubbed library to build
Huh. We can try. I hadn't thought about that. So if we go here and zig out...
You don't need any build magic then.
We have this host.o. Let me make sure it's the Linux version. I don't remember the command for... Actually, do you know where those files are saved? Because I know you generate all of them. Are they in the platform?
You just put them in platform, yeah.
Ah, they're already there. Okay, so if I just go zig build exe, and we pass in platform/Linux, and then can I just pass in the shared library? Do I have to do anything else?
That's it. Yep.
Oh wait, I need to target.
Detarget. Whatever.
What is it? Do you know Linux? What's the? I can look at the. Give me a second. I'll just do this. We go back over here. It's right over here.
x86_64 dash Linux.
Got it. So go back. Undefined reference to symbol_main, but main should be in that x86 Linux object file. We should try to do this the proper way, but I guess we can't just hack around it because it's missing main. Well, actually, let me just bundle again, because I had changed something with the bundling to rebuild those files and skip that. So if we run this again, nope, still missing main. Can we do -lc? No. Okay. Weird. I don't know why we don't have a main. Oh, I know the issue. It's trying to link as if this is Mac OS. It's trying to link for Mac OS still. Mac O flush, and _main is a Mac OS thing. In Linux, it's just main, not _main. So Zig is not cross-targeting correctly right now. I don't have any ideas why that is. I don't know if anybody in chat has any ideas, but but Zig is totally trying to do a Mac O build right here, even though we're saying target Linux. I'm really not sure as to what's causing that. We have the dtarget command. But yeah, we can just try to do it on the Zig side of it instead, or like the Zig build side of it instead. That's like the more proper way to do it anyways. So we generate this output, and then we would tell it to build, but a different, with a different like subcommand. I forget how to do this on Zig. This might be where my Zig diving fails me and it ends up being problematic. Oh, is it just .target for exe? Okay, let me try that. It doesn't look to be. Oh, let's see.
Is it worth looking at the symbols for libapp.so on your Linux machine and just confirming that
I actually did
is
this
what we think?
before the stream with a version built on Linux, and it definitely was correct. That's actually why I changed it to the object file and did a few little changes of that sort. So I'm pretty sure that should be correct.
Okay.
Okay, let me type this into less. Yeah, .target. Arch OS ABI. Oh, there's more that we need to pass into this, isn't there? I need to do dash GNU. Aha! It's trying something.
Oh, wow. Very cool.
Interesting.
Okay.
Warning, cannot find entry symbol underscore star. That's a Mac OS thing. Okay, so our issue we're hitting right now is that it's using the Mac OS linker and trying to link for Linux and not configuring things correctly. It may also be partially my fault for having LLD set up, and maybe there's some sort of issue it has with LLD. But that's not a Roc issue. That's a Zig cross-linking issue using my LLD here. But we can still try one other thing here. I guess I'm going to try to do this. This is definitely not as much in my wheelhouse, but let's try to define an executable with a shared library dependency. Zig has to be able to do this, obviously, even if I don't know how to do it. And so, you know, I'm assuming we're going to need basically the same setup as what we had for the object file, but it'll be an exe, and we'll call add executable. Whoa! I have a Zig autocomplete in this. I have not had that before. That's actually really nice. Actually, yeah. Except it's not force pick. It should be force pi for an exe, I think. We will call it dynehost because that's the traditional name, not that that really matters. We need to install it, I think. So that'll be install artifact, I think.
Yep.
Yeah, and that's just going to be exe. And then the only other thing that this is missing is that it obviously needs the shared library. I don't know how to do that with Zig, so let's go to their docs.
Depends on the library above it.
But it doesn't depend on this object file. I want it to depend on the Roc shared library we just generated, right?
Stublib. Yeah.
Yes, I want it to depend on that stublib, exactly. Libapp.so. So we go to their docs. We zoom in because everything's too small by default. We go here, we go build. Go to their builder API.
Which version? We're running 11, yeah?
So there's shared library options. Oh yes, we're running 11. Let me update to that. I think it has less pretty docs though. The real loss. Yeah, it's the less pretty docs. But right here, there's probably an add. It won't be add shared library because that already exists, right?
There is an add shared library.
But that's to build a shared library, which I don't think is what we want. Let me look real quick. Because I think this will build a Zig shared library, if my understanding is correct. Maybe I'm wrong there. Oh, I guess let me just go back to the add exe and see if I can like add a dependency to it. I know the alphabet. E is up. Oh, man. Optimize, linkage, libc. No, it doesn't have anything about other files to link against. But you said there's also the depends on part, so it may not be this that happens to have it, but actually the compile step, which might have a depend on shared library or something of that nature.
Add object?
Add object is what generates a .o file.
All right.
Yeah, so a lot of this is about the Zig generation
Add shared library?
side of it. That'll generate a shared library with Zig. I don't think it works to like add an existing shared library. I guess we can test it and see. But that's my understanding is that's just for.
Puts out a compile step.
Oh, add library path. That's probably what we need. Okay, let's try that. Come over here. Go. Add library path. It's a lazy path.
Compile.
So dot path, and it's gonna be what? Platform / lib app dot so. That's not going to be generic enough for all different systems, but we'll start with that. Let's see if that builds. Sig build -e target.
Is that going to run on every time you do zig build?
I think I need to correct it so that it only runs on the Linux targets, but for now I'm going to ignore that and
you
just
could have a zig build shared or zig build stub lib or something.
Oh,
or platform exe.
First PIE does not work. Okay, so I'm assuming it's just. I'll just leave force pick on. And I know that's not quite correct, but maybe it'll do what I want it to do anyway. I think PIE is default anyway, so it's probably not a problem. Let's see, will this work? Moment of truth. It's really taking its time.
Suspiciously long time.
Yes, very much a suspiciously long time. I don't trust that at all. Is there a verbose I can pass in this to see what it's doing? Yes, I'll just do -v. No, of course, there's not -v dash verbose link, I guess? It's probably going to print out way too much information, but let's see if we get something working here. Yeah, I feel like something's wrong here. Okay. So we might have to leave the Zig side of this for a different time to dig into. But at least we have the base roc command. It'd just be nice if I could figure out a way to available within package. Oh, do I not have the depends on things that we need? Okay, that's at least progress for sure. Wait, okay.
Ah, yeah, just do add module.
Yep. Let me copy those for the exe as well. But that's definitely progress. Okay. I guess I don't need the verbose link anymore, but maybe that's what was really throwing it off, is not seeing that stuff. Okay. But if this generates a dynehost file, we can at least test this command, which is what I'm really hoping for. Okay, it thinks it's generating a dynehost, debug x86 Linux. Oh, I guess the other part is you may want to do release builds eventually. Okay, this error is very non-obvious. Where is this failure?
That's where the stublib is meant to be providing that. Wait, that's defined in host.
Okay, what is it missing? Oh, no. This is exposed from the stublib. The stublib should be providing this, so we're not linking to the stublib correctly, is what that says. Oh, because it's not going to be lib. It's just going to be libapp, I think. Platform / libapp. Because you normally don't put the .so or. Man, I wish I had a more intimate knowledge of how Zig does this. Because the path. Let me just do this and see what it does. Because normally when you link against a library, you add a path, and then you just say you're linking against app or libapp, right, is the normal way to do it. And so that's why I'm a little confused, because they add a library path, which is probably where the library is, which the library is in platform. So then we probably separately have to add a specific library? Not fully
add object file?
We could try that. But add obj copy, add module. But I think fundamentally that's the issue, is that we're incorrectly doing what's required to link to this library.
So instead of adding the path for the library, you add the object file itself.
Yeah, we can try. Let me try this first without the .so because I know that's normally how linkers expect it. You end up linking against the lib app, and it figures out .so version or, you know, .obj, etc. But yeah, this is the main function that the host is providing. So this definitely should be in that lib app.so. Yeah, no, still not finding it. Because it is adding this -l here, which is kind of correct. Because I think what we really want to see, so if I copy this command actually, what I think it really should be, if we take this command, is it should just be -l to platform, and then we add link to app. Why did I get the extra 0.11 there? Is that actually running? Okay, that doesn't seem to actually run for some reason. It just prints out the version. But that's my understanding of what we actually want here. Is we say we're linking to something in this directory, and it's the library called app. And in Linux, the library called app will resolve to libapp.so.
Yeah.
And so it's definitely what I expect to work overall. Let me get rid of this weird listen thing.
What if you go zig build exe and put the SO file in with verbose link and see what it pops out, how it does it, links to it.
Oh, did we just get it to work? I think that just worked. Except I built it manually. Well, I see a dynehost.o. That's not exactly what I expected. Oh no, there it is. Yeah, that did work. We have dynehost right here.
Nice.
Okay, so that means at least we can test this. So roc, preprocess. Well, it's going to actually be almost the same args to this. So we'll do preprocess host. And then what was the other argument? So we need the example application, and then we need the dynehost, right?
Mm-hmm.
Oh, obviously I can't just call roc. It's going to be roc/target debug. I think I only did a debug build.
Mm-hmm.
Why does it expect example/dynehost? Okay, let's copy this dynehost into the example directory just to see if it's some silly... Hey, it thinks it worked. And there we go. We've generated a .rm. Where the heck is the .rh though? I think there's something I've pipelined wrong here. We have a dynost, the dynost file I copied in. We have the .rm file, and yeah, did I put the .rh in the outer directory? Linux x64. That's intriguing, to say the least. So I'm going to guess I have something pipelined here wrong. So let's go back to
I found something weird with shared libraries about like where you link them against. They expect it to always be in the same relative path or something.
Yes, that's definitely an important part, is the relative path. No, I don't think that's what we're hitting here, because I think we didn't generate the .rh file at all, so something weirder is going on here. Right, so we know that our main app path is correct, because it's going to be the exact same thing that's passed into this gen stublib. And we can actually rechange the name because it's not the platform path anymore. It's so we'll just change this back to input path, just because that's more correct. So the question is, what is expected here, and are we doing something wrong about that? Because this probably doesn't expect the input path. It probably expects something different here. If I go back to preprocess host, yeah, this expects the platform main file. So we're definitely doing something incorrect here. What do we actually use this for? We use it to make the metadata file name, and we use it to find the dyne host. Yes, okay. Interesting. So,
Because the Dyn
oh,
host should be sitting next to the main
I
platform
know what I
name.
did wrong.
Hmm.
So, okay, if we go back to this main file here, undo that. So, this is the main. This path is really just where we're generating things, and so they wanted the app main. This is not supposed to be the executable's name. This is supposed to be the output file's name. So this should be the .rh file. And so what I just did in this other part here, if I scroll back up here, is I overwrote this dynhost file, and it's actually now the .rh file because I passed in the wrong name. And so we need to generate the correct name here. That is totally my bad here. We're just overwriting the dynhost. Let's see, what time is it now? It's almost 7 now, which I think is about when I want to end this. We almost have this feature working, but it's literally just a matter of something being misnamed and then figuring out the zig side of building this. But hopefully the people that watched, they at least learned a thing or two about some of the Roc platform side. You know, this is a very simple addition to Roc, besides me not remembering how things work. But I'm pretty sure if I just do a little bit of path mingling here and correct some names, everything should work out okay. In fact, if I go back to this generate stublib here, does it use the platform path at all? Yes, it does. It gets the platform path from loading the application. And so that's where I made a big mistake, is I need this platform path. And then I need to modify other things. I guess I can try to finish this real quick, because I think it's just a matter of also returning this platform path and then using it. So 2 path buffs now. Totally not going to confuse them ever. So we have that. And so I'm just going to copy this because I know I'm going to need this exact same thing. Like I probably need to do like what, into? Or is it in? Cool. So if I go back to our main library here, where's that? Here, our main file. We now modify this so we also get the platform path from that. And this is where everything should be anchored to. Now that we have the platform path, the platform main is just going to be platform path.with file main .roc. Is with file name not on a path buff? Expected path. Oh, I need to just reference this. And then we can also do, for the executable path, it's going to be platform path.with. Oh, I don't have the full name. I mean, I know I'm just going to hard code it for a second. x64.rh. Because that's the output path, is what this is supposed to be. Why is this still not happy? Oh, no, there it goes. And so now that'll be generating correctly. And we actually don't need to pass in the platform executable, because it will grab that directly from the platform directory. So we don't actually need to pass that in, which means we can remove that from here. It's actually not needed.
Makes sense.
We just need to make sure to move that into the platform directory, because that's where we're going to build all these things. Okay, and so now if we go back here and we go cargo build, I guess I should just build Roc. I don't need to build anything else. And this is the problem with putting my thing to sleep. I need to let the language server finish running. That's always a minor annoyance. There we go. Okay, so still have to do a little bit of name cleanup and some pipelining of just some basic stuff of that, like which .rh file. Of course, now I have an import that's wrong. That's in main.rs. That makes sense. Clean that up real quick. make the same mistake again of not letting my language server finish, and this is my only problem with this setup right now. But the easiest solution to that is just run your commands in a second terminal window. Let this build out. And so now we should have a valid version of the binary. We just need to move dynahost to the correct location, and we should be able to make this all work. Man, linking Roc is not a fast prospect. Okay. Go back to Roc graphics. We're going to copy the dynahost, but into platform, because that's where it's supposed to be. And now if we run that command again, oh, it doesn't take dynahost. Yes, invalid argument. Good job. It knows what it's talking about. Shared library not found is a dependency of the executable. I know what happened here, I think, but so we're not quite there. And this is on the Zig side again. We're back to the Zig side. In that, I probably can't objunct this, can I? It's going to break. Let's see. Will this objunct dump for me? I can't talk. And then we also do a 2, 2, 1. Oh, it will. Cool. If we look at this and we go to, where does it show this? Not the symbol table. Where do I see what's linked against? I thought that would come before the symbol table, not after it. There's a lot of crap in this binary. Just do lib app. No, it's not coming up. Huh. What we should see is that it's linked against lib app, but it looks like it's not at all, which is really, yeah, it should be in this section here. We didn't. It's not dynamically linked against the application. Something is still busted. Okay, but this is on Zig side. I need to figure out the correct magic invocation for Zig here in the build.zig. I don't know it yet. But that's fundamentally our problem, is we just need to get Zig to correctly generate this application that links against a shared library. I wonder if there's like a link or something. If I type in link here, not linker script, not linkage.
There's an add object file.
Link objects, that might be it, propose link. But add object is how you add an object that Zig is building. So I don't think that'll be the right add object. I mean, if we want, I can try it, but I'm pretty sure that's not correct here. Keep going. Where's actually something with link outside of these variable names? Add VPC path, add link framework. That might be it. There link libc. Link library. That's probably what we need as well. Or link system library. Link system library name. Link system library needed. I'm going to try link library. Well, this takes a compile step, so not link library. I'm going to try link system library and see if that does what we need. That's probably what we want. So we go. So we need the path to include platform, because that's where libapp.so is. And then we want to link a system library. Yeah, it will be nated, so I'll try this. And the library is just the app library. Let's try that. Zig build. Oh, I don't need verbose link anymore. Let's just get rid of that. But, okay, here we go. I think this will maybe actually work correctly. And then we just need to make like a special condition to only build this when you put in the names. So, like make it not build by default, but build on a specific request. Okay, that actually worked. So now if we go to zig out, we see zig out/bin. We see the dynahost file. And so I'm going to copy, let me first remove the one in platform. I'm going to copy zig out, bin, dynahost, to platform. Now if we do this roc command, it works.
Wow, awesome.
Okay, so besides final pipelining, we may have everything. If we go look at the platform, we see Linux x86 or x64.rh. And where's the metadata? And the Linux x64 metadata. Yeah. Okay. So that is all of the pieces now in place.
That's
I mean,
great.
there's the tiny bit of cleanup to not hard code this name here. And maybe a little bit of making the API a bit nicer. And of course, the little bit of Roc graphics cleanup so that this only builds when you request it, because you don't want the Dyn host to build on every platform. Obviously, you just currently want it to build for Linux. And
Just make a run step.
yeah, exactly. Make a specific step just for this that you can like call out to. But with that, we now have those RH and RM files, and you should be able to distribute this such that it can use the surgical linker.
It's awesome. Thank you.
Look at that, just barely finishing. But yeah, I think that's going to be all for today. If anybody has any last minute questions, if Luke, you have any comment you want to say, or last minute things, we can do that for a couple minutes before I wrap this up.
No, I think this is very awesome. Sort of what we've achieved today is that we have a platform, a very basic platform, but a platform in Zig, which you can run a simple bash script and it will build, cross-compile the platform for Mac OS and Linux, bundle it up, enable the surgical linker, can distribute a URL to that package, and things will just work for people who have a Roc running locally using a nightly build, for example. So that's very exciting.
Yeah, I think the awesome thing about this is like when you're using a language like Zig, where it's super easy to cross-compile, you basically can do that and also get all the Roc pieces working. So there's no weird dependency of like, oh, because of Roc, I need to actually run this on Linux or run this on Windows or whatever. As long as we expose this sort of functionality, everything can be cross-compiled fully. And so theoretically, even now that I have that .rh file, this is getting into dangerous territory, but I should test this real quick. Let's try this. So if I go build example / roclovesgraphics.roc, and I go target is, what did we say this was? Linux -x64? This works as well. So we just built a Linux binary of the Roc application on macOS. And I guess if we want to take this one step further, I can see if I can SCP.
Using the surgical linker.
Yes, using the surgical linker. So examples / roclovesgraphics to, let me grab my host real quick.
So you just need to try it now in the Wasm compiler in the
We'll
browser.
Throw it into temp.
Good.
And now if we go over here and we SSH in, let's see if this works. I wouldn't be surprised if there's something broken, but we'll try it. Seg fault. Okay, there's still something off. We're closer though. We'll have to look into that and see what's actually going on. But
can you object dump it?
Yeah, I should be able to object dump that and see what. Yeah, I wonder what we're missing. But the file as a base looks okay. It still doesn't claim to be linking. Oh no, we preprocessed it, so it's no longer linking the application. Yeah, never mind. That's normal after you preprocess it. I mean, it looks still the same for the most part. If I search Roc, do we see our Roc functions? Yeah, they were all of our. Oh no, those are the. Oh no, yeah. So here's the Roc actual application right here. Is this Roc host 1 exposed generic? And then all of the helpers for Roc to work. So it should be good. I guess I can do one other thing real quick. I go back over here and I go Roc exposed 1 main host, and we jump down here, keep going. Let's see if I find, let me just do Roc E, because I think that'll search for Roc exposed. Huh, it didn't find it. Yeah, so there's still something missing, but don't have time to debug that today.
Host. Yeah.
But, oh, is it Roc main for host exposed? Okay, so Roc main, Roc M. That's not going to be enough. Roc main. Am I missing something? I just saw it the first time. Roc underscore
Just double
MAIN.
underscore.
Ah. Let's see if we find another. Jump to Roc main exposed. Call Roc main exposed. This looks like, wow, lots of locations for this. Let's see if we can find a definition real quick. It'll be like the last use is probably the definition. Why does this have so many calls to the main? That seems incorrect to me. Well, not very easy to find the last call to something if there's like a million calls to it. Okay, this probably isn't worth just going through for forever. Okay, but yeah, something's still missing here, and so it didn't quite work, and so we'll have to dig into that at some other time. You know, I can write with GTV. Apparently, memset is seg faulting related to muscle. Oh, Zig built with muscle. Interesting. That actually may be part of the issue. I may just, real quick, if I go back up to here. No, we won't go through all of this right now, but it may be that we need to essentially tell Zig to do things with GNU and then correct things or something of that nature. Because my system is set up for GNU. But you'd think muscle being static would just work. But things for another day to dig into and find out. But yeah, hopefully people learned a thing or two from the stream. At least we got like the foundation of this working. And now it should just be a matter of some of the more basic pieces connecting the dots, right? To get everything working. I mean, I guess I'll give this one more try before we fully give up. Copy that again. Oh, let me remove the old version. Do that. Copy this over again. We'll give it one more try, this time with the GNU version, just see if it works. Or did I build the application? Oh wait, no, I need to preprocess first, right? Preprocess. And then build. Let me remove that file one more time. SCP it over. And this will be our last test, and we will see. Let's see, do we get it? Nope. Stack smashing detected. Okay, so yeah, it's not fully there yet, but at least we have the basis for it. I'm assuming that these issues are actually on the Zig side at this point, and we're doing something incorrectly with Zig to get this set up. But I don't know. Not sure. It could also just be that linking on macOS doesn't do things as expected by linking on Ubuntu, and that causes issues. But that's for another stream for sure, or something off stream to do. Anyways, everybody, thanks for watching, tuning in. We'll see what happens next time, but I'll probably end up finishing at least some of the cleanup and getting this submitted as a PR to Roc off stream, just because that would be pretty boring. It's mostly commits and wrapping things up. But yeah, thanks everybody for watching. Luke, any last words?
No, thanks. This has been good fun.
Okay. Well, I'll be uploading this to YouTube, and I will see everybody later. Talk to people later. There's OBS. Bye, everybody.